x. I like to call it n of x. You don't have to. It's not important. Minus. So I have the top, which is the function, which is natural log of x squared plus 2 minus 3x over the square root of x squared plus 1. And this, I didn't write it correctly. It has to be this, the equal symbol, the negative sign, and the fraction line have all to be on the same row. I don't like what I did there. All these have to be lined up. So natural log x squared plus 2 minus 3x over the square root of x squared plus 1. Now, finding the derivative here, it's an ugly situation, right? So let's start with the natural log. I have 1 over x squared plus 2 times the inner function prime. Remember, I always say times the inner function prime, which is 2x. So I'm going to write it here, 2x. Minus 3 is a factor because there is nothing else that follows here, so leave the 3 alone. This is ugly to differentiate. It's not friendly at all. And imagine putting this in the graphing calculator. Okay? Top function prime is 1 times the denominator minus top times the denominator prime, which is 1 over 2, the square root of x squared plus 1 times 2x. And here I will simplify the 2 over the denominator squared. Okay? So let me try to simplify it one more step if I can, a little bit. It's just okay. There's nothing really I can do about it at the top. This is just what it is. In the numerator, 3, the square root of x squared plus 1 minus, I have maybe I should find the least common denominator here. That would be better if I do that. I can try to simplify it a little bit. Yeah, I will find the least common denominator, and when I multiply, the square root goes away. What will I do without my whiteout? Okay, so I need to multiply this by the square root of x squared plus 1. So that's how I get 3 times x squared plus 1 minus x squared. Don't forget there is a denominator here times this. So again, I couldn't do anything here, and I'm not going to continue. Oh, maybe I can simplify this. I see a little bit. Okay, so I have to, I simplify the 2 with a 2. Then I have a negative x squared, and the least common denominator is the square root. I multiply these two, I get this. And 3 was in front, so I need a 3 here as well. Because 3 was completely outside, and now I have to distribute it to the top. So this times this, and this times this. And it's nice because these two will go away. Okay, one more step, I promise, last one. Natural log. The more I simplify it here, the easier it will be to put in the calculator. Okay, the 3x squared with minus 3x squared will go away, and it's just 3 at the top. I'm not going to go any further with this. So I'm just verifying my calculations one more time. So this was the function correct. I copied it correctly. And then this one more time. Yes, 1 over x squared times the inner function prime minus 3 stays outside. Top prime is, yeah, minus times this prime. 1 over 2, the square root, times the inner function prime. These two go away, so I have x squared. So then 3 times this, correct, and minus 3x squared, correct. 3x squared plus 3 minus 3x squared, and that changes into positive 3. That's it. Now all this mess in the graphing calculator. And like I always do, and sometimes I forget myself, don't delete anything in the calculator. Don't delete anything. Okay, because I don't want to put this in again. All you have to do is just insert, put an X, put a minus, put a left parenthesis, go all the way till the end, and put a parenthesis for the numerator completely outside. And now we're going to fight with the denominator. It will be a fight. Okay, I need parentheses. Now, 2x over x squared plus 1, that is not too bad. In parentheses, I have to have x squared plus 2. And close. And now minus. 3 is okay. But when I divide, I have to put parentheses outside. I will have several sets of parentheses. Careful. So this is for the denominator. This is for x squared plus 1. Close. Now the square root. And x squared plus 1. Go outside of the square root and put this parenthesis, the pair of this. But remember, we need one more. The pair of the beginning of the denominator. Oof, it was a long one. Okay, so now second and quit. We go to variables, y variables, function. At this point, let's stop for a second. We have to decide. I have to decide whether I start with 0 and 1. It's a big decision. I have to make sure, if I want to start with 0, I have to make sure that the denominator is not 0. So this could be 0. It is be 0, that's fine. But this will not be 0 because this is 1 and 1. So I'm okay. I can start with 0. So the analysis has to be made, because if you plug in 0 and this denominator, the derivative is 0, then you're not going to get anything. I forgot to check how many decimals. So you tell me, well, how many decimal digits we want? 8. Fine. Good. So I'm sharing my screen again. Okay. So we decided to start at 0 because we can. And this is our first iteration. I expect a solution between 0 and 1. So this is my x1. 0.23104900602. Let's see x2. For x2, this is the only time I change. I copy, I overwrite with the previous answer. Make sure there is nothing else in there. And this is my x2, or x sub 2, or the second iteration. 0.24835777047. And now I only continue like this forever. Enter. Okay, 2486, 2411, so I have one more, but let me write this down. So I have to write x sub 3 and x sub 4. So please write all the iterations step by step. So x sub 3 is 0.2485241199. X sub 4 is 0.248524136. And I think the last one will probably be redundant. Completely redundant. So this is it. I'm not going to copy the last one because there is no point. I can stop. These are the same. So if we want 2, 4, 6, 8 digits. Very good pick. A lot of calculations were needed. because I wanted to make sure that I put in the simplified form, because otherwise this is way more difficult to plug in the graphing calculator. I can easily make an error there. And now you see why my appreciation for parentheses. I know somebody who has appreciation for clouds. I have appreciation for parentheses. So coming back here, just to make sure, I used parentheses here. There is no need here. I use parentheses here. There is no need here, but of course here you need parentheses. And you need parentheses here. Absolutely. Unless you put 3 divided by this and further divided by the square root. You can do that. But if you omit these parentheses or these parentheses or these parentheses or these parentheses, you're not going to get anything. It was a very good problem. Yes. Next question. Yes?
Professor, if we have a question like this in the test and let's say we plug it in the calculator and it doesn't give us the right figures, is it going to be wrong? Like, are we going to get no credits for the answers?
You either didn't enter the function correctly or you didn't start with the or you started somehow that there is a max or min between the starting point and the actual solution. Maybe the function has a trig function in there, and maybe you're still in degree mode by mistake instead of radian mode. So you have to look at those things. I always give partial credit if the function is correct, if the derivative is correct, etc., etc. But you have to present the iterations. And if you don't present the iterations, then the problem is not correct, entirely correct. Very good question. Thank you. Excellent questions, all of those. I love the interaction with my students. That's the most important thing for me. To answer your questions, because I can't think of everything that you can think of. So I can answer ahead of time. So I can't do that. So they always help me. Any question. Never a silly question. I never consider a question to be silly, ever. Next topic. Anything else?